Hello everyone, Assalamu alaikum. Welcome to today's session. Ahlan wa sahlan, guten tag, konnichiwa, hello. All right, if you are joining for the first time, in the description of the video, you can get the questions for today's session. We are looking at recurring decimals into fractions. So we're looking at 10 questions. So press pause, have a go. If you're stuck or you are ready for the answer, press play. Okay, so this says prove algebraically that 0.73 recurring can be written as 11 over 15. So what does 0.73 recurring means? It means 0.7 and 3 carries on forever. Okay, so that's what it means. And the question is telling us we have to write it as 11 over 15. So that's a fraction. Now it's paper 3 from June 2020, which is a calculator paper. So they've actually given us the answer. So if you get your calculator out, and if you put into your calculator 11 over 15, it will give you 0.73 recurring. So you have that. So we know that this works. So how do we solve this question? What do we do? So the first thing is we need to label this as x. So we label it as x equals to 0.73 recurring. Okay, so that's my first step. Let me write out the steps as I do this. So step 1, let x equals, so that's my first step. The next thing I'm going to be looking at is I can see that I'm going to turn this into a whole number. So there are 2 place values here. So I'm going to be multiplying it by 100. So I'm going to say that this is now 100x. So 100x equals, this becomes 73.3. I'm just going to write it out a bit more so you can see it's like that. So 73.3 recurring like that. So that's my second step. So step 2 is multiply by tens, okay, or place value. Okay, so that's my second step. And the next step, and I'm going to kind of demonstrate it, is I'm going to look at aligning x. So if I put here this 100x equals 73.3 recurring. And if I put x underneath it, x equals 0.73 recurring. You can see that the place values are not in alignment. These are not aligned. Okay, they are not aligned. So I want them to be aligned. I want the 3 to go here. So I have to shuffle the 3 one space to the left. So that means I need to multiply x by 10. So I need to multiply x by 10. That gives me 10x equals, this now becomes 7.3 recurring. So you can see that they are now aligned. Okay, and also make sure you have this layout. If you have this layout, it's much easier to see things. Okay, so that's my second step. Let me write this out before I forget, or the third step rather. So step 3 is to align the decimals. Align the recurring decimals. Recurring decimals. So I have to multiply again by tens. Okay, so for the first one, it was 100x, so it was 2 place values. On this occasion, it's 1 place value. And now I subtract them. So 100 take away 10 is 90. Say it in your mind, just so that you could play it. And now you can see that the decimal points cancel out. So I'm left with a 0. And then 73 take away 7 gives us 66. You can use your calculator. It's a calculator paper question. So I've got, excuse my daughter in the background. I've got 73 take away 7. Let me just deal with my daughter. Oops, give me a second. Oopsie daisy. My daughter's not feeling it better. So here we are. So 73 take away 7 is 66. And now I need to solve for x. So I'm going to be dividing by 90, divide by 90, and then I simplify x equals to 66 over 90. And now I need to see what do I need to divide by. I keep simplifying this until I get to 11 over 55. Now that this is a calculator paper, the good thing is I can just see how do I go from 66 to 11. So I can just do 66 divided by 11 gives me 6. So I can just divide by 6 the top, divide by 6 by the bottom, and I get that. So 11 over 15. And you can just double check that as well with your calculator. It does work. Okay, so step 1 was to label it as x equals to my decimal, multiply by powers of 10. Then I need to do my next step, which is to align them. And then step 3 is to subtract. And then I solve for x. Step 5 is to keep simplifying. Solve for x and keep simplifying. Okay, so these are our steps. We're going to follow these steps to make sure we get that right. So in the description, feel free to write if you got that right or not, or in chat. Okay, let's go to the next one. Slightly different from what I normally do. So I've looked at the papers as I do each time. This time I've printed it out. So recurring decimals to fractions. These are all higher questions. And I've looked at 12 sets of papers, and you can see how often they appear in paper 1, paper 2, and paper 3. So you can see it appears, it's mainly a paper 1, but it also does appear in a calculator paper. So it's a non-calculator lot, but it does appear in calculator papers. So 10 out of 12 times from what I've spotted from the different exam papers. Here's the next question. Let's go to the next question. Question number 2 of 10. Express 0.117 recurring as a fraction. You must show you're working out. So this is worth 3 marks. Press pause, and when you're ready, press play, or if you're stuck, press play for the answer. So here it is. Express 0.117 recurring. So I've written that out just in case you can't see it well. So I'm going to get my steps back again. So I'm going to call this x. So this is x equals 0.117 recurring. So now I want to multiply by my tens so that I get my place values correct. So this, you can see there are 3 place values there. So this is going to be 1000x equals to 117.1717. I'm just writing out just so that I can see. Okay, so it carries on. The next thing, so that's step 2. Step 3 is I need to align the recurring decimals. So you can see here, after the decimal point, it's 17. Here it's 11. So I need to shuffle it 1 space to the left. So that's going to be 10x. And if I shuffle it 1 space to the left, it becomes 1.17. 0.1717, and you can see that they are now aligned. So now that I've got my step 3 sorted, I can now move on to the next step, which is I subtract them. 1000 take away 10. So again, read this in your mind. Say in your mind, 1000 take away 10 is 990. Many times I've seen students write 999 or 999, which is a shame. It's a little mistake, so they lose a mark. So here, this is 990, and again, the decimal points cancel out, and so this is just 117 take away 1, which gives me 116. And now I need to do my next step, which is to solve for x and keep simplifying. So here I am going to be dividing by 990. 990. X equals to 116 over 990. Now, if I read my question, it says express 0.117 as a fraction. And this is a fraction, so I don't need to just keep simplifying in this case. I'm just going to pause there. So that's it. So I can do more, and if you do more, because you'll see, as you see from these questions, you might just by habit keep simplifying. You still get the correct answer, but I'm not going to do any extra work because I've got other questions to think about in the exam. So well done if you got the same answer. Let's move on. Here's a nice quote I came across. Courage doesn't always roar. Sometimes courage is the quiet voice at the end of the day saying, I will try again tomorrow. And this is a quote by Mary Ann Radmacher. So sometimes when you're doing maths, it's not always easy. You might be struggling, but sometimes you just have to come at it again tomorrow. So don't give up, keep trying, keep working hard. The next question is paper 1, November 2017. This is in the exam paper, so we're going to ignore this question. We're going to go to question number 15 at the bottom of the page. So this question is x is 0.436 recurring. Prove algebraically that x can be written as 24 over 55. Press pause and have a go. When you are ready, press play for the answer. Okay, same thing again. Let's get our steps. So step 1, we've got x as that. Now I need to see how many place values I've got so that I can move it across. So that is 3 place values. So that's going to be 1000x equals to, when this jumps across, this becomes 436.36. So I'm just putting that there just so that I can see I've got everything aligned. Now my next step is alignment. So after the decimal point, I want 3. At the moment, this is 0.4, so I need to shuffle it 1 space to the left. So I need to multiply it by 10. So this now becomes 4.3636 recurring, and I can see that the place values are now aligned. So I do my next step, which is subtract. 1000 take away 10. Again, read it in your mind. 1000 take away 10 is 990. And now the decimal point cancels. 6 take away 4 is 2. 4, 3, 2. This is a paper 1, so we're not allowed to use a calculator. So now we keep, they've given us the answer here. So we want to get to this. So before I do that, I haven't solved for x. So divide by 990 again. Divide by 990. So x equals 432 over 990. Okay, so now I'm looking at what number goes into both the numerator and the denominator. Now I am going to keep it simple. I can see they are both even numbers, so I'm going to divide by 2. Divide by 2. Half of 400 is 200. Half of 32 is 16, so 216. Half of 990, if you want to chunk things, so 900 490. What's half of 900? It's 450. What's half of 90? 45. Then add these together. 594, so 495. Okay, so I've done that now. Again, I've got another even number. So I could have done divide by 4, but again, I just like to keep things simple. Divide by 2. Half of 200 is 100. Half of 16 is 8, so it's 108. Oops, I can't do that because this is an odd number. I didn't look carefully. Silly me. All right, so this is an even number. This is an odd number, so I can't divide by 2. So what number do they go into? The next number, prime number, is 3. Well, does 3 go into them? So the trick to these is you add the digits, 2 plus 1 plus 6. And whatever the answer is, if 3 goes into the answer, then it's divisible by 3. So that's 9. 3 goes into 9. Let's do the same thing for 4 plus 9 plus 5. 4 plus 9 is 13, plus 5 is 18. And again, 3 goes into them. So it's divisible by 3. So I'm going to do short division here. So I'm going to do 216 divided by 3. If 3 doesn't go into 2, carry the 2. 3 goes into 21 7 times. And it goes into 6 2 times. So this is now 72 over. And I do the same thing, 495. 495 divided by 3. Does 3 go into 4? It goes in once, remainder 1. 3 goes into 19. 3, 6, 9, 12, 15, 18. 6 times, remainder 1. 3 goes into 15 5 times. So it's 165. Okay, now again, I can use the trick I did here to see if it's divisible by 3. 7 plus 1 is 9, so 3 goes into 9 as well. 1 plus 6 is 7, plus 5 is 8, 9, 10, 11, 12. 3 goes into that, so I can divide by 3 again. 3 goes into 7 twice, remainder 1. 3 goes into 12 4 times. So this is now 24, which is what I see here, and I'm not even going to bother with doing the next bit. It's going to be just 55. If I was in the exam. Now, just to prove to you it works, I'll still do the division of 165. Divide by 3, carry the 1, 5 times, remainder 1, and that's 5 times. So you got that. So divide by 3, divided by 3, and here I didn't write divide by 3, divide by 3. So that is it. So I've got my decimal, recurring decimal, and I've shown that it can be written as that number. So there I have it. So well done if you got the same answer. Let's go to the next question. This one is from paper 1, November 2018. This is our 4th out of 10 questions. This is the first question on that page of the exam paper. We're not going to answer that. We're going to skip to the bottom. Question 16. Press pause and have a go. If you're stuck or you want to see the answer, press play. So prove algebraically that 0.256 recurring can be written as 127 over 495. Okay, so it's similar to before. Again, same thing. It's you can see from my decimal, it's got 3 place values. So same thing as before. Step 1, let x equals to that. So I'm going to say x equals to this. Okay, and now I'm going to look at my place values. Step 2, what am I multiplying by? My tens. How many place values do I have? 1, 2, 3 place values. So I'm going to call that 1000x equals to 256.56, and the 56 is recurring. Okay, so that's my first thing. The next step is I need to have them aligning. So I need to put them in the right place value. So I need to, after the decimal point, it needs to be a 5. Here it's 2, so I need to shuffle it across one more space. So that's 10x equals to 2.5656. So that's recurring. Now I need to do my subtraction. So these cancel. 256 take away 2 is 254. 1000 take away 10 is 990. Remember to do it in your mind. Typical mistake is 999. So now that I've done it, I can now divide by, I need to solve, so divide by 990, divide by 990, x equals to 254 over 990, and I can see I want to get to 127. If I divide this by 2, I get to that, divide by 2, divide by 2, and so I can just write this out as 127 divided by 495. Okay, I don't even need to do anymore. That's enough. But let's, prove to ourselves that this works. Half of 200 is 100. Half of 54 is 25. Half of 50 is 25. Half of 4 is 2. Add them together is 27. That's 127. Okay, I'm not going to waste any time doing the same thing with the next one. And you can see it's coming up all the time. All right, well done if you got that answer. And again, if you're here for the first time, subscribe to the channel. If there's any topics you would like to revise, then comment and I will see if it is possible. Here is the next question, the fifth question of our 10. Press pause, have a go. When you are ready, press play for the answer, or if you're stuck, press play. So prove algebraically that 0.123 recurring can be written as 61 over 495. So that's what we want. Now again, just like previous questions, this is a calculator paper, so they have given us the answer. So again, just to kind of show you, if we put 61 over 495, it becomes 0.123. So the calculator is there. It's not really going to help us on this occasion. So we do need to show our working out. So what are the steps? Exactly same as before. So we're going to call it x equals to 0.16, 123 rather. And so this is how many place values? 1, 2, 3 place values. So again, 1000x equals to 123.2323. So they're going to be recurring 23. All right. Now, I need to align them. So after the decimal point, I want the 2. So how many shuffling do I need? I need this to shuffle across one step. So times by 10, that gives me 1.23. So you can see the decimal points are recurring. The alignment is correct. I subtract them, my step 4. 1000 take away 10 is 990. Again, similar to what we've just been doing for the last 4 questions. And now the decimal points cancel. 123 take away 1 is 122. And now we solve for x, and then we want to keep simplifying until we get to that. So divide by 990, divide by 990, x equals to 122 over 990. Now, what number do we need to divide them by? We can keep simplifying, but we are using a calculator paper. So let's get our calculator and use it. So I want to go from 122 to 61. I don't even need to do that. I can do it in my head, but just to prove to you, it's 2. There we are. So we're dividing by 2, top and bottom, dividing by 2, x equals 61 over 495. Hopefully you got that. If you did, like the video. All right, so let's see if anything is different in the next question. Okay, so this is now from paper 1, November 2019. Pause and have a go, or if you're stuck, and then press play. If you're stuck, press play. So let's do this. Question 15, express 0.418 as a fraction. You must show all your working. Surprise, surprise, it's very similar to what we've just been doing. So you can see the pattern. It's very, very routine. It's very, very similar to what we've been doing. So again, let's get our steps out. Let's call this x. x equals to 0.418. How many place values do I need to multiply by? 1, 2, 3 place values. So that's going to be 1,000. X equals to 418. And it's going to be 18 after that. So it's 18 recurring. And now that I've done this, I can then look at my next step, align the recurring decimals. So this needs to shuffle across how many? So it's 0.1, it's 0.4 at the moment, so it needs to shuffle across to the left one place value, so it's times by 10, 10x equals 4.1818 recurring. The next step, I subtract them, and then I solve for x. So now 1000 take away 10 gives me 990x equals, the decimal points cancel, 418 take away 4 is 414, 418 take away 4. And now I want to remove the 990, divide 990 by both sides, x equals to 414 over 990. Let me read the question. Express as a fraction. We don't need to simplify, so I'm going to stop there. So you can see this question in a way is easier than the other questions, but this is how it is. All right, well done if you got that correct. Here's the next question. Oh, and if you are finding this video helpful, share with your friends. And let's go to the next question. I can move the page. There we are. Oh, this is slightly different. What is this question asking us? So this is from paper 1, November 2021. Pause and have a go. All right, so question 13. Ted is trying to change 0.43 recurring to a fraction. Here is the start of his method. X is 0.43 recurring, 10x equals to 4.34 recurring, 10x take away x equals to that. Evaluate Ted's method so far. And it's a 1-mark question. And so normally what I will do with questions like this is I will actually ignore all of this. I'm going to ignore all of this. So if I just get a piece of paper and I'm just going to cover this for now. So you can use your hand in the exam or whatever you want to do, just cover it. So let's go back to our basics. What are our steps? So our steps are this. So we're going to call them x equals to 0.43 recurring, and then multiply by our tens. How many place values do I have? I've got 2 place values, so 100x equals 43.4343. Okay, so I'm going to do that. And now I'm going to compare my working out with what's written there. So the next step would be x can just stay as it is because it's 0.4, so it's in alignment. So x equals 0.4343. Subtract them. 99 take away 1 is 100 take away 9. 100 take away 1x is 99x. And so these cancel. This is just 43. Divide by 99. Divide by 99. I'm going too far. But, you know, you do it. And now you compare your answer to the other bit. So let's look at this. X, that's what we did. We did the labeling. 10x, whereas we've said it's 100x. So this is Ted's mistake. He should have multiplied by 100. So let's write that down. Say what you see. Ted should have multiplied x by 100. So that it becomes 100x equals to 43.43 recurring. Okay, and that's enough. So you've stated what he has made as a mistake, he's done as a mistake. That's your 1 mark. All right, so this is slightly different to what we've done before. And so you can see practicing exam questions, how useful it can be. Let's go to the next one. The next one, this is from paper 2. So it's a calculator paper, November 2022. This is the first question on the page. We're going to ignore that. And let's go to our question, which is question 14. Let me cover that with a piece of paper. Press pause and have a go. Okay, so this question says, using algebra, prove that 1.062 can be written as 1 and 14 over 225. So again, it's slightly different from the other questions. All right, so what are our steps? Our steps are exactly the same. All right, so step 1, let x equals to that. So x equals 1. Let me just get this right. My paper's moving a bit. Okay. So let x equals to 1.062 recurring. So how many place values do I have? What do I need to multiply in terms of my 10? 1, 2, 3 place values. So I've got 1000x equals to, what do I have? 1062.2 recurring. Okay, so we've got that there. Now, my next step is alignment. So how many place values do I need to move? So I want it to be 0.2. At the moment, it's 0.0. So it's 0.062. So I need to shuffle it 2 place values. So it's 100x. So now if I shuffle this 100, shuffle it to the left, it's 106.2. Okay, so my place values are now in alignment. I subtract 1000, take away 100 is 900. And so these points are cancelling. So I got 1062, take away 106. I can just get my calculator out, use the calculator. The small luxuries that you get sometimes in a test. So 1062 take away 106 gives you 956. 956. Now I've done now I need to solve for x. X divide by 900. Divide by 900. And I keep going because I want to show this. So x equals 956 over 900. Now, how many times does 900 go into that? It's once. What's my remainder? 56 over 900. And so I want to get to 14. So again, we have the luxuries of a calculator. We can do 56 divided by 14. What do we get? 4. So I can just divide by 4. So I can divide the top and bottom by 4 here, divide by 4 there. So x equals to 114 over 225. Okay, so, oops, I'm not seeing that. There we are, 1 and that. So that's our answer. So hopefully you got the same answer there. Well done if you have. Let's go to our next question, 9 of 10. We're nearly there. So this question is from paper 2, November 2023. And you can see we are on question 13. Press pause, have a go. So prove algebraically that 0.0723723 is recurring, can be written as 241 over 3,330. All right, so it's paper 2, so I am allowed a calculator, so that might be helpful. This is slightly different from what we have had before. Slight difference. But guess what? Our steps are the same, so the process is the same. So we're going to call this x equals to 0.0723, and now I'm going to see what step 2 multiply by the tens, my place value 1, 2, 3, 4. So that's 1, 2, 3, 4 zeros. So that's 10,000x equals all of that. So I can ignore the zeros. It's 723.723, because that's what's being repeated. Okay, so now I've got that. And now after the decimal point, I want the 7. So how many places do I need to shuffle this time round? It's going to be 1, 2 places. Is it 2 places? Sorry, it's 1 place. Why did I say 2? So it's 0.7, so it needs to shuffle across 1 spot. So that's 10x. And so this now becomes 0.723 recurring. So the recurring parts are in alignment now, so I can subtract. So this cancels, and I've got 7, 2, 3, and I've got 10,000 take away 10, 10,000 take away 10 in your mind, 10,000, and it's 9,990. But use your calculator if you want to do that. 9,900 and x equals to that. And now I just need to solve, so I need to divide both sides by 9,990. Did I just say something and make a mistake myself? 10,000 take away 10, 9,990. Yeah, that's correct, but I've written something different here. 9,990. I knew something was wrong. 9,990. X equals 723 over 9990. And now you can get your calculator. What do I need to divide by? So 723 divided by 241. What's my answer? I just divide by 3. Could have just looked at the denominators, but hey ho. Divide by 3, divide by 3. X equals to 241 over 3330. And that's what they want. So well done if you got that. And if you're thinking, is there a topic I'm going to cover, feel free to post a message in the comments, and I'll see if I can cover that. We are on our final exam question of today's session. So well done if you've gone through all of these questions. This is from paper 2, June 2017. Press pause and have a go. Using algebra, prove that 0.136 recurring times 0.2 recurring is equal in value to 1 over 33. This is different to the other questions that we've been doing. So it's quite different. So it's exactly it's actually, if we think about it, pause, because if we just carry on with what we've been doing, it's not the same. But if I think about it a little bit, I've got a recurring decimal recurring decimal here, and I've got another recurring decimal here. So I need to change these to a recurring decimal. So I have another step for this question. So normally I have my steps here, but on this occasion I have to do this twice. So I've got to change these. So I don't know if it's a step 0, but change each. Let me put it as step 1 actually. Step 1, change each recurring decimal to a fraction. Then my answer I'm going to multiply. Step 2, answers, I'll put it like this, multiply to get 1 over 33. Okay, so now that's that. Now in order to do change the recurring decimals, I follow my steps. So I'll get my other steps back in again here. And so let's just carry on with this. So first things first, I'm going to say, let this one be x. X equals 0.136 recurring. Okay, so how many place values do I have? 3 place values. So this is going to be 1000x equals to 136.36 recurring. And then after my decimal point, I want it to be a 3. So how many places do I need to shuffle across? It's a 1 place value, so that's 10x. So this is 1.36 recurring. Now I can do my subtraction. 1000 take away 10 is 9,990. Sorry, 1000 take is 990x. Now I can subtract my place values. 136 take away 1 is 134. 135 rather. 135. 6 take away 1 is 135. And then I am dividing this 990. X equals 135 over 990. Now I can keep simplifying. Now this is the beauty. If it is an exam calculator paper question, I can just put this into my calculator. What does this simplify to? 135 over 990 simplifies to 3 over 20. 22. Okay, so what did I divide by? Let me just see. So I've gone from 135 divided by 3. That gives me 45. So I've divided by 45. Divided by 45. Okay, so that's the first one. Now I need to do the same thing to the other one. So again, x equals to 0.2 recurring. I want it to be, I just need it 1 place value here. So 10x equals to 2.2 recurring. Then I can just put x underneath it because it's same place value. The recurring decimals are in alignment, so I can subtract the point. 2 take away 0 is just 2. 10x take away x, 1x is 9x. So now I can just divide by 9. Divide by 9. X equals to 2 over 9. So now I've got changed these into recurring, into fractions. So now I can just put 3 over 22 times 2 over 9. And I can see vertically I can't do anything, but diagonally I can cancel out. Divide by 3. Divide by 3, that becomes 1. 9 divided by 3 is 3. And here I can divide by 2. Divide by 2. 22 divided by 2 is 11. 2 divided by 2 is 1. 1 times 1 is 1. 11 times 3 is 33. And that is what they've asked me to show, 1 over 33. So well done if you have done the same. If you've enjoyed the video, let me know what topic should be next. Thank you for staying with me. Take care, everybody. And I'll see you on the next one. Bye-bye. Assalamu alaikum. Guten Tag. Auf Wiedersehen.